A two-stage rocket developed and manufactured by SpaceX, known for its safe, reliable, and cost-effective access to space. It's also the first and currently the only orbital class rocket capable of reflight. Sitting at the top of Falcon 9, Dragon and its trunk stand over 26 feet tall. There are two windows on the spacecraft, plus one under the nose cone. The nose cone opens shortly after launch to expose the forward bulkhead thrusters and docking mechanism that will connect to the space station. Dragon's trunk holds solar cells, which power Dragon while it's in free flight. The trunk can also carry unpressurized cargo.
Dragon has 16 Draco thrusters that can be used in space to help navigate the spacecraft to its destination, each providing 90 pounds of force. That doesn't include the 8 Super Draco thrusters used for an abort, which are no longer active once the crew is in orbit.
Dragon has played a significant role in advancing our future in space by safely transporting crew to and from the space station. There's currently 4 Dragon spacecraft supporting human spaceflight missions that have docked to the station, and those are Endeavour, Resilience, Endurance, and Freedom. Designed to be the safest spacecraft ever flown, Dragon is capable of carrying up to 7 passengers to and from Earth orbit and beyond.
Crew 9 is SpaceX's 15th human spaceflight mission since 2020, when Dragon became the first private spacecraft to take humans to the International Space Station. Dragon has completed over 47 launches and flown 54 astronauts, representing 14 countries. Throughout all of those missions, Dragon has helped support more than 1,000 experiments. Altogether, the reusable Dragon spacecraft have completed 8 human spaceflight missions on behalf of NASA and visited the station 42 times under NASA's commercial resupply and commercial crew programs.
And through all of that, Dragon has proven to be quite a versatile spacecraft. It can autonomously dock to the space station when outfitted with the ISS docking adapter, as it is for today's flight. When not going to the space station and in free flyer mode, the docking adapter can be swapped out for a cupola. Then, of course, you have our newest option, the Skywalker hardware, to support extravehicular activities, which the crew just used for the first time during Polaris Dawn. Continuing down the vehicle, we have the second stage. The second stage is powered by a single Merlin vacuum or MVAC engine, and this engine is optimized to perform in the vacuum of space. After stage separation, the MVAC will ignite and carry Dragon to its target orbit. The Falcon 9's first and second stages are connected by the black interstage, which houses the MVAC engine and the systems that decouple the two stages during stage separation. Below that, of course, is the first stage, which is powered by 9 Merlin engines. These 9 Merlin engines provide the initial thrust to lift Falcon 9 off the pad and clearing the tower through the lower, thicker parts of the Earth's atmosphere. Each of these 9 Merlin 1D engines delivers about 190,000 pounds of thrust at sea level, and that gives Falcon 9 a combined 1.7 million pounds of thrust.
After stage separation, Stage 1 will return to Earth for recovery and reuse on a future mission using a combination of the Merlin sea-level engines and the 4 titanium grid fins located near the top of the booster, which will guide it during its re-entry and landing. The Falcon 9 first stage is also equipped with 4 landing legs that deploy just before landing to allow for a vertical touchdown on either a drone ship or a landing pad. And today, we'll be attempting to land this booster at Landing Zone 1 back at Cape Canaveral Space Force Station. The second stage will power Dragon into its initial low Earth orbit before separating, leaving Dragon to continue its journey to the space station using its own thrusters. About 40 seconds after separation, Dragon's nose cone deploy sequence will begin, exposing the guidance navigation controls that help Dragon autonomously fly to the space station.
With